Today we're going to be talking about absolute values and the use of inequality equations. Now the idea of an absolute value is actually pretty simple. In some ways you're just making any number into a non-negative number. So if you were to have, say, -7, and you want to take the absolute value of that, you're just going to knock off that negative value and put it equal to 7. But that's kind of a base level understanding of absolute values. What you're really doing is seeing how far away something is from 0 on the number line. For instance, if you and a friend were to, say, meet at the same McDonald's, and you were to drive 5 miles north, and the friend were to drive 5 miles south, you would both still be 5 miles away from that McDonald's. But you'd be a total of 10 miles apart. That's essentially the same thing, but you're not measuring whether it's towards the negative side or towards the positive side, just measuring the distance traveled on that number line. If we were to have 0 here, 7 over here, and -7 over here, there's still going to be a total of 7 units to get to 0. Now, when you're talking about inequalities, you're going to be using the greater than sign or the less than sign, and also these could be less than or equal to, or greater than or equal to, or less than or equal to. Essentially, you're saying that the one on this side is going to be greater or less than one on the other side. So, for instance, if you have x is greater than 7, x could be any number in which is bigger than 7. That could be 8, 7.5, 10, 12, 13, up to infinity. So you really can't definitively say what that x is going to be. However, you can give the range of 0 all the numbers from 7 on to infinity. Now it's important to remember that inequalities are essentially equations. So if you were to have x minus 3 is greater than 7, you can do some fancy algebra, add 3 to both sides, and come up with the equation x is greater than 10. Essentially, inequalities are the same as equations, except you're not using an equal sign, so there's not a definitive answer as to what x is going to be. Alright, let's jump back to absolute values before we try and combine the two. So if we were to have the absolute value of x is equal to 7, we couldn't definitively say whether that x is going to be a -7 or a +7. Because remember, if this x could be absolute value of -7 and still be equal to 7. Alternatively, x could be absolute value of a, ooh, that's a big 7, absolute value a +7, and that would also be equal to 7. So essentially, when you're solving for x in an absolute value equation, you're not going to have a definitive answer because there could be two different solutions. Later on in math, you'll find the same thing when you're squaring an x, because remember, a negative times a negative is going to be equal to a positive. So -7 squared is going to be equal to a +49. In the same way, +7 squared is equal to 49. That's not exactly applicable to the problems we're going to be working on, but you get the idea. You can't definitively say whether it's -7 or +7. Fortunately, when you combine these two concepts, they're not nearly as hard as you would think they would be. So let's start off with an easy one. Absolute value of x, and just for simplicity's sake, we're going to say is less than or equal to 2. Alright, now we got two concepts at work here. If we were just take this by itself as x is less than or equal to 2, we would basically be saying that every number 2 and below on the number line, whether that be 1, 0, -2, etc., it could be x. Alternatively, if we're saying the absolute value of x equals 2, we could be saying either -2 or a positive 2. So if we look at this on, let's say, a makeshift number line, we have 0 here, 2 here, -2 here, and both of these extend on to the great beyond of infinity. So what we're saying is that because our original equation of absolute value of x is less than or equal to 2, so we can definitively say from just this part that it's going to have to be either 2 or something less than 2. Now, because we have the absolute value here, we know that if it's, let's say, if x were to be -3, that wouldn't be true because the absolute value of -3 isn't going to be less than or equal to 2. It's going to be a positive 3. And 3 is not less or equal to 2. 3 is, in fact, greater than 2. So we're going to create sort of a stop point right here, because we know if you go anywhere past -2 on the number line, you're getting bigger negative numbers, and if you're going to make those into positive numbers, they're going to be bigger than your original 2. So if you were to say -4, x equals -4, that is going to turn into a positive 4, which is greater than 2, and that messes up our inequality. So if we stop right here, we can say x is going to be equal to anywhere between positive 2 or -2, but anything else out here doesn't fit our equation. And similarly, if you were to say x equal to positive 4 is still going to be bigger than 2, so we can get rid of anything here, and so we're finally left with our solution set, which is going to be between 2 and -2. Now, how we express that is you're going to be either drawing it on a number line or sort of expressing it in this way. So we have x. Now we know that 2 is going to be greater than x, greater than or equal to x. And alternatively, we know that x can't be any more negative than -2. So we know that x is greater than or equal to, if I'm doing this right, -2. Now I believe that is correct. I'm hoping on this one. Alternatively, we could write that as it's between the set of -2 and 2. Alright, now let's try a different problem. Let's say the absolute value of x is greater than or equal to 2. Now, the same problem worked, except it's going to be reversed. We're saying that the x is bigger. While that might not seem like it makes a big difference, let's take a look on our number line here. It's not a very straight number line. 0 to positive 2. I just got a text. Alright. Now we know that, let's see what our original equation up here. Absolute value of x is going to be greater than or equal to 2. Alright, so conventionally, we know that if you just take x by itself without the absolute value, we know that x is going to have to be equal to either 2 or anything greater. That means 3, 4, 5, on to infinity. could any one of those numbers could be x. Now on the other side of the scale, over in the negative, remember when you substitute any number in for x, you're going to be taking a non-negative version of that number. So if you were to take -1 and put it in the place of x, it would turn to +1. And +1 is not greater than or equal to 2. Hopefully that shouldn't be a point which is difficult. But if you were to take -2, put it in there, it would turn to +2. And +2 is equal to or greater than +2. They're the same thing. Now let's take, for instance, -3 and put it in there for x. Now you're going to be chopping off that negative sign, turning into a +3, and +3 is greater than or equal to +2. So what we're saying is +3 works just as well as +2, or -3 works just as well as -2, and if you were to take 4, put it in there, chop off the negative, you'd be getting 4 is greater than or +2. So we're going to say -2 works, but so does any number from -2 down on to -infinity. So that's pretty easy to figure out. Essentially, on our last problem, when the known number was greater than x, we were taking all this in here. But for now, all this in here can't be can't be equal to x, because then you're getting a number that's less than +2. Now how we actually represent this solution is going to be a bit different. This way we're going to have to start off by saying we're going to have a parentheses. Now we're going to put -infinity as our first point in the data set. Remember last time we had -2 and +2. This time we're going to have -infinity, and that goes on forever, and then -2. So essentially this expression is saying anywhere between -2 and then somewhere off in the distance to -infinity. If you remember on our number line, I wish I didn't get rid of that number line. That represents all this up here, which could be a possible solution for absolute value of x is greater than or equal to 2. Alright, now we got this half of the graph done. Now we're going to do our other half, which is 2, +infinity. And put a parentheses there to show that's open-ended, goes on forever. And I said, okay, so now we have both of these two sets. In the same way, this represented our old set of all this in here. That's drawn on my eyes. So does this represents all this up here, and this represents all this up here. Alright, so we've sort of put it together, and now we're going to put the U sign, which essentially is saying this is going to be the union of these two sides, and is essentially if you were to take the U and put it into English language, you're saying -infinity all the way to -2 and +2 all the way to +infinity. So that's how you solve basic inequalities with absolute values. Stay tuned next time, and we'll be getting a bit more complicated problems as we solve for what do you do when you have numbers inside your absolute values.